You may recall from Chapter 2 that we learned that arsenic is a poison because it mimics the behavior or chemistry of phosphorus, and both elements are in group 5A. The lethal dose of arsenic can be as small as 100 milligrams, and worked example 6.3 asks us to calculate the moles in 100 milligrams as well as how many arsenic atoms are in 100 milligrams. So this is a question where we're converting between different types of amounts, and when we do those types of calculations, it is imperative that we are really clear about which bucket we're starting with and which bucket we're going to, based on this flow chart that I showed you earlier. So I tend to label what we're starting with by G, as in given, and I tend to label where we're going to as W, or wanted. So in this problem, we're given 100 milligrams of arsenic, and from our unit, that lets us know that we're in the mass bucket. And so to get to moles of arsenic, our conversion factor is molar mass. Now, one of the things I notice is my unit is milligram, and to be able to use the molar mass as a conversion factor, our mass has to be in units of grams. So before I can actually use the molar mass as a conversion factor, I've got to convert from milligrams to grams. So on the bottom of the slide is the equality between milligrams and grams. 1,000 milligrams is equal to 1 gram. So whenever we convert from one unit to another, we use our equality, the relationship between the two units, and we multiply this equality in a ratio form by the amount that we're trying to convert from. So we're converting from 100 milligrams, and we multiply by this conversion factor where 1 gram is in the numerator, and gram is in the numerator because that's the unit that we want, and milligram, 1,000 milligrams, is in the denominator because that's the unit that we want to cancel out. And that's always what we'll use to determine which unit goes in the numerator, the unit we're trying to get to, and which unit goes in the denominator, the one we're trying to cancel out. So milligrams divided by milligrams cancels out, the unit of gram does not cancel out, and that's the unit of our final answer. So let's look at the math now. 100 multiplied by 1 is 100, and then divided by 1,000 is 0.1. Now your book wants to use 3 sig figs here, so it expresses as this answer as 0.100 grams. So now that we have our mass in grams, we can use the molar mass as a conversion factor. And for atoms, the molar mass is found on the periodic table. Arsenic is in family 5A. Its molar mass is 74.92 grams per mole. Now your textbook likes to round to the 10th place. I like to round to the 100th place. I'm not concerned about rounding. In Canvas, I will usually specify how many places after the decimal point your final answer should have. I really care about the process. So if you're just off by 1 or 2 digits from the correct answer, that's not going to be so much of a big deal. All right, so now we know that our mass is 0.100 grams. We want moles. Here's our conversion factor between moles and mass, or our conversion equality. 1 mole of arsenic equals 74.9 grams of arsenic. So we start off with 0.100 grams of arsenic, and we multiply by the conversion factor. Since grams is what we want to cancel out, the 74.9 grams goes in the denominator of the conversion factor, and 1 mole of arsenic goes in the numerator. Looking at our units, grams of arsenic divided by grams of arsenic cancel out, and we're left with units of moles of arsenic, which is the units of our final answer. So let's look at the math now, which our calculator handles. 0.1 multiplied by 1 is 0.1, and then we divide by 74.9. And your calculator will give you as many digits as it can handle, but we're going to round to 3 digits and express this answer in scientific notation, because that's the technique that your book chose to do. So 1.34 times 10 to the minus 3 moles. Here's our last allowable digit. That's 3. I look to the right. That's a 5. So this 3 gets rounded up to 4. Okay, so we were able to go from mass of a sample, once we got to grams, to moles of a sample by dividing by the molar mass. Now, part B asks us to determine how many atoms there are in that sample. So if we look at our flow chart, this bucket number of atoms, we can only get to from moles, and we get from moles to number of atoms through Avogadro's number. Well, we just calculated the number of moles, so we know what that is. We have 1.34 times 10 to the minus 3 moles of arsenic, and here is our conversion equality. 1 mole of arsenic is equal to 6.022 times 10 to the 23 atoms of arsenic. So when we do this calculation, 1.34 times 10 to the minus 3 moles, that's what we're converting from, we'll multiply by the conversion factor based on this equality. So moles of arsenic is what we're trying to cancel out. So 1 mole of arsenic goes in the denominator, and 6.02 times 10 to the 23 atoms goes in the numerator. Again, your textbook is rounded more than I would have, but that's okay. So looking at our units, moles divided by moles cancels out. Our units are atoms of arsenic, which is what we want. We take 1.34 times 10 to the minus 3. We multiply it by 6.02 times 10 to the 23, and we get 8.07 times 10 to the 20. I didn't mention that we divide by 1, but anytime you divide by 1, it doesn't change the value, so that's why I didn't make a big deal about that. So I just want to point out this number is huge. 10 to the 20th is absolutely humongous, but that is what we would expect for the number of atoms or molecules in a measurable sample. And by measurable, I mean mass measurable, such as 100 milligrams. If you get an answer of 10 to the 20th grams or 10 to the 21st grams, something like that, your answer is wrong, because that is a mass that is almost the mass of this planet. So you will never get a mass that large. You will only get these incredibly large numbers when you are calculating correctly the number of atoms or molecules in a measurable sample. By measurable, I mean we could weigh the mass in the lab.